Okay, so there's a discrepancy between the code that I've given you initially and the one that I'm testing for. So the PDF is correct, just the code that was in there is not correct for some reason. I need to remove this load factor function that you've probably just seen, and I changed the constructor so it only takes a size. And of course, now that I've changed that, I need to open up the CPP file, bless you, and change the load factor as well. We'll talk about a load factor next class. Let me make the insert test again just to make sure. I had a feeling something would happen. 0.8. So we need to go over here and get rid of that 0.8 load factor. Perfect. Okay, now we're back to where we need to be. Okay. So initialize size. Source hashtable.cpp. Okay. Size. How do we give it the initial size?
We create size number of positions in the vector, which are of lib lists.
Okay. Yeah, so mtable is a vector, so you probably do mtable.reserve of the size. You remember the reserve function made sure it had that many capacity inside of your vector. Okay. Actually, I think that's all we need to do. All right, let's go ahead and do int, since that's what we're testing for. Note that later on you will need to put in the string in order to pass all the test cases from the autograder. But if it's passing in a key, just as an integer, we're just going to return that for now. Okay, this is kind of a lame hash code function. But I want to show you that if it's a string, you need to do something else. Can anyone guess, whoops, what that might be?
Do you need to cast it to an integer?
You can't just directly cast a string to an integer. Was there another formula that we used that might have been useful?
Add up the values of the letter.
There we go. Add up the values of the letter.
And that's just for
The string. Yeah.
Well, what necessarily are you doing with hash code? Are you trying to?
We're converting the key into an integer.
Okay.
So normally your key is an integer, which makes it really easy. Sometimes it's actually very common for it to also be a string, so you need to do something else that might be helpful.
Add up 1 plus 8 plus 5 plus 4 plus 1.
Well, that's an integer.
0 plus 3, yeah, okay. Yeah, no, you wouldn't do the above.
Okay, do it that way. Okay. All right. And let's see, what else do we have? Oh, let's go ahead and do this one, or get started on this one. Don't forget your destructor, what you think about that. Let's see. And of course, with all these long function declarations, it's good that once you type it out, see if it compiles. It did, great. Okay. Now, we're in the insert test. We want to we need to, oh wait, that was an insert. Whew, that was bad. That's operator subscript. We need to insert. Key, and it's probably const v at value. Let me make sure I did that correctly. Yep. Let's make sure that compiles. Nope. Probably because it's a void function. Or is it a Boolean? It's a Boolean function. Perfect. Okay. So what's the formula here?
a size variable? Like, because we were talking about doing the modulus thing with the size of it.
Mm-hmm.
Do we need one of those, or do we? Or
What are we storing the size of?
Oh, sorry. What did you say?
So, okay, we need a size variable. We need at least to have access to the size, but what do we need to have the access, or what size do we need to have access to?
The array.
The array. Do vectors already give that to us?
Oh, yeah.
I mean, that's a legit question. Let's find out. I don't know why this website is always terribly slow. Oh, looks like the answer is yes. You just call vector.size. Huh. Can we go back to vector so it makes sense? Oh, just vector. There we go. Size. Return the size. Actually, you're really looking for capacity. How much storage has been put into the array.
Because there could be empty positions.
Yes. It's how many elements can be stored in the array / vector. All right. So we have that piece of information. What else do we have? Or what do we need to do? What's the first thing we need to do?
Should we have created a variable to hold that value?
Create a variable to hold.
The capacity value?
Okay. Well, I mean, we could just call it as well. But sure, we'll create a variable for it. And capacity, or we're talking about the size, so we'll just have size equals mtable.capacity. All right, that's fine. All right. We could do that first. What else do we need to do?
Come up with something to insert it to and distribute it to.
Okay.
A formula.
Mm-hmm.
So are we doing the modulus way of doing it?
We'll have to, yes, eventually. What is
So-
key right now? What's key's type?
Okay.
Okay. Is that what we need it to be?
No, we have to call hash code.
There we go. Now notice down here we have hash code for an integer and a string. So right now it only work for an integer and a string. If we need to add some other type, there would be another function for it. But this will convert the key, no matter, or the key depending on whatever type it is, to an integer. We probably should store that into something. What should we call that variable?
Storable. Storable.
What are we going to use that hash code to do?
It's going to be index.
Index. So we should call this variable index. All right. So we have the index that we want to add. Well, we have we at least have an index. Is that index necessarily correct?
No.
What do we need else we need to do?
Need a modulus at minus size.
Mod it by the size. So I'm going to do that in one line. There we go. Actually, we'll make it 2 lines just to make the code readable. I just realized the comments might be a little confusing here. So next we'll have index mod equals size. Size down the size variable so it indexes into the array / vector. All right, doing good so far. Now what do we do?
Need to check and see if there's nothing at that position.
Do we need to do that if we're doing linked list or hashing with chaining? So it's always a list there. In open addressing, yes, we would have to do that check, but we're doing chaining, so we know it's a linked list. So what do we need to do?
Just add it to the end of the linked list in that position.
All right, how do we do that?
an STL for?
Sure. I'm going to get you all to write this piece of code, not me.
So we need to go to the vector position.
All right. So what do I type first?
Your M table.
M table.
At index, right?
Yeah, so
Sub index.
sub index. There we go. So what is that right now?
That's where you're going to insert.
Right, but what's the type of M table sub index?
It's linked list.
It's a linked list.
Yeah.
So we're going to
We're gonna say like, do we use like,
So let's go over and look and see what a list provides us.
does it provide us with an in?
See, modifiers. Modifiers are functions you can call on the object. Which one of these looks great?
Push back.
Push back, add element, add in. Yeah, that sounds awesome. Let's go look at that function. And you pass it a value. Awesome. Which is whatever you templated it on.
This is beautiful.
Push. What do we pass it?
The value.
Value. Oh, wow. Okay. Is that a lot easier than anticipated?
Yeah.
Well, I can give you a hint, this is wrong.
Dang it.
But you're close. This is actually very close. And I'm not going to fully write this function for you, but we're going to start evaluating this function, which will tell us why insert is wrong. But first off, let's make sure it compiles. Man, we are awesome. Look at that. Compiled the first time. Good job, guys. Okay.
Yeah, it's wrong.
It is wrong. So if I were to do hash table dot, I already forgot what function, dot insert, we'll say 99 maps to 9001. Then I need to ts assert equals that ht sub 99 is equal to 9001. Segfault, yeah. Okay, obviously this sub 99 is just not working whatsoever. That's because we're not even returning anything. Okay, so hopefully this will make sense. I'm not going to write the code for this, but let's go ahead and comment out what needs to happen here. What do we need to do first? We have the key. We need to
Hash code. We need the hash code.
actually, what can we do? What can we pull any lines of code from our insert down?
We can pull the first 3 lines down.
First 3 lines down. All right, so I didn't write any code. I copy and paste it, so I haven't lied yet. All right. Yet. All right, now what do we need to do? It's gonna be
We just search through the linked list at index.
all right, so we're going to first get the list at mtable sub index, then search the list for
Key.
what's being stored in the list.
The value.
Can we search for a key right now?
No.
So what's the problem with our hash table?
Not starting the key.
We are not storing the key. We need to store the key and the values inside of our linked list.
So, will we have to change our constructor?
So we are close. So we don't want to template on a value. We want to template on, but we need to store the value because we need to get it. We need a template on both. So we need to,
Make 2.
okay, we could make 2 lists. Let's not do that.
Okay.
Instead, we could,
2-dimensional.
no, not 2D lists.
Put an array inside the
Put a vector.
Oh my gosh, y'all are making this way too complicated. All my OOP teaching has gone out the window for this class, that's it. Remember, that list can be a list of anything. A great of,
Keys and values?
what are you doing? Of just multiple keys and values, or just values? Wa,
A key value.
a key and a value.
Okay.
Yeah.
So we're just going to template it on a pair, and that's a PAIR, not the fruit.
Dang.
Are you sure?
Yes. So class pair, public, m key, v m val. Oh, okay. We're just gonna make them public for now. Whatever. It'll be fine. It'll be fine.
So we are doing a vector array of linked lists, and the linked lists are pairs. Each element in the linked list is a pair.
Yes.
Okay, now I can finish my project one.
What's this?
So maybe I can finish project one now. My own.
No. The STL will betray you if you try and use it for
Yeah, you
project
can't
one.
use, yeah.
You can try and use vectors for that one. You will be very sad. Well, you might, actually no. There's a way to do it, but I recommend against it. Okay. All right. So yes, you have an array of linked lists of pairs. All right. So let's go back into insert, because obviously this is not going to compile anymore. Let's go and try and compile it. Push back, we can't push it back. We need to push back on a pair. See, it needs to be a pair. So it's not that. What do we need to do?
We need to create a pair.
We need to create a pair. Pair.
Pair.
Here, how about this? To insert. To insert dot m key equals the key dot m val equals val. All right, then what are we pushing back?
To insert.
All right, let's see if that compiles. Perfect.
Segfault that.
Right, it segfaulted because we called this and we're not returning anything that makes sense. Remember, let's comment out the line that's segfaulting. Oh, it's still segfaulting. Whew. I'm a dirty rotten liar here. All right, push back to insert. Sub index. Is index not correct? Ooh, let's find out what the issue is.
Do we need to put parentheses around im table subindex?
No, because this is being created on the inside of the class itself. We're not using pointers. We're using a class to wrap everything around, which is probably making most people's lives a lot easier. Let's see what index is. So I'm feeling that's going to be the issue. Index equals 99, which is fine.
We modded it by something then.
Hold on a second. I bet you, I think I know what the problem is. Yeah, that's what I thought. Okay. So modding it by 99, so we're getting a proper index, but we're still getting a seg fault. What do you think's going on here?
Is it because like the list is empty at first?
Yeah, you have the capacity of 100, but you haven't actually put in a linked list for each element.
Yeah.
Okay, where does that need to be done? Constructor, all right. Wow, I just went to autopilot. Oh. Now I'm kind of confused here because it needs to be because it's a vector of lists. Actually, that doesn't make sense, right? Why would you have a pushback error? Let me see something here, because this doesn't actually make much sense right now. Sorry guys, hang on.
You're good.
Every once in a while, you forget something in C++. So m table sub index, we're just gonna see what that is right now. So we're looking at it. It is something that cannot be printed out. All right. Can we call size on it? Bless you.
Thank you.
No problem. We can call size. So let's call size on it and see if that is allowable. Or if it's just going to seg fault again. Oh, the size is 0. The size is 0. That makes sense. No, that makes sense. So we don't need to automatically create each one of them. It's already done for us. Then why is the pushback seg faulting? Because we got the size, and then when we push it back to insert, it's giving a seg fault. Let me make sure this isn't some weird memory error real fast. So it's not a weird memory error. There's something wrong with pushback. That's odd. Can we push front? Maybe that's what it wants to do. I didn't think that would make a difference. Wow. I'm actually stumped at what the issue is. Huh. Because we made it of lists, right? Okay. Size, capacity, iterator equals constructor. Let's see if there's a constructor list we need to look at. There shouldn't be. It should just have empty constructors. Yeah, that just has a standard allocating type. That's perfectly fine. And then we want to push back. That's the value. Effectively increases the size of the container by 1. Yeah, we're good. All right.
The way that we're reserving it.
Yeah, I have to say this is odd. Let's see, do we compile with debug flags? Yeah, we did. All right, so GDB, let's go hook it up to the debugger. Oops, the test runner's right here. Let's see run. Oh my goodness. $99 and 100, search table line 22. That's definitely the problem. Line 22. Yeah, we're on line 22. Huh. Did I make it a list? I made it a list. Just for fun, we're going to change that to a vector. Let's see if it does the same thing. Yes. No, we need, vector doesn't have push front. It only has push back. Okay. There's something weird with list going on here that I'm not familiar with. So we'll make it a vector of vectors for now. Pretend they're a linked list. Just pretend for now.
All right, we'll pretend.
Until I figure out what's causing that, because that's odd.
So what about for our lab? Do you want us to do vector?
Yeah, that'll be fine. It's going to be fine for the lab. It's not going to be that big of a deal. Okay, well I'm going to have to figure out what's causing that, because that was not intuitive. Well, anyways, now we have a list of pairs. So first get the list, search the list for, now what are we searching it for?
Searching for now.
For
On the pair.
the key. And then we return,
Value.
yeah. All right, there we go. And that's going to be it for this lab. I'm going to figure out what's causing that list issue. It's going to drive me nuts for a while. All right. Any other questions?
And so we also need to implement remove.
Yes, you'll have to implement remove. Vector has an erase function.
Perfect.
Yeah, that's nice.
STL here,
Now, yeah, if we just start using the STL from here on out, that's perfectly fine. I have no issue with that.
any libraries besides hash, right?
Yeah, the whole point of doing the whole arrays and list was to make sure you understand how they work. That's the point. Now that you understand how they work,
Don't have to worry about it.
let's make it easy, right?
Oh, finally.
Yeah.
Vectors.
Yeah. If I taught algorithms, it would really be data structures part 2, but we would just be using the STL, all the time for all our things. You wouldn't be going nuts with so many of the intricacies of pointers and whatnot. You'd just be concentrating on the algorithm. But anyways, that was a side note. All right, that's going to be all for today. You now have, oh great, you have plenty of lab time. You have an hour and 35 minutes. Please get started. Don't forget your project.